Okay, which of the following models this function? So that means when we have x is 1, we need to get f of x is 4. When x is 2, we need to get f of x is 16, and so on. So let's see. When x is equal to 1 here, we get f of x equals 4. So that's good. Let's keep testing them out. Here when we have f of x equals 1, f of x would equal, plugging in 1, we would get 0. So this one can't be it. Here when x is 1, 4 to the 1 equals 4, so that could be good. Here for choice D, when x is 1, f of x equals 1 to the 5 is just 1, so that's out. And then similarly, this one's also going to be out. So now it could be between these two. So let's try when x is 2. Here we're going to get f of x equals 5. That's wrong. For this one, this is going to be our answer because when x is 2, we get f of x is 16, because 4 to the 2. When x is 3, f of x, 4 to the 3 is going to be 64. And then when x is 4, f of x is going to be 4 to the 4, which is going to be 256. So this is our answer. Here, this f of 4 equals 2 means when I plug in x equals 4, the result is 2. So let's try that. When I plug in x is 4, 4 plus c, the result is going to be 2. Or f of x is going to be 2 when I plug in x is 4. So now we're going to do a lot of these questions, so don't worry if you're not sure. Square both sides. 4 plus c equals 4. So then minus 4, c equals 0. So we're going to keep doing these. This means when I plug in x is 3, I'm going to get 10. I'm going to get f of x equals 10. So I'm going to plug that in. 2 times 3 minus c in absolute value, and I'm going to get 10. Now we have to know how to solve absolute value. We did that before. 2 times 3 is going to be 6. So you get 6 minus c equals 10, and 6 minus c equals negative 10, like we did in chapter 2. So you should remember how to do that. Minus 6, so minus c equals 4, divided by negative 1. So c equals 4, that's one possible, and minus 6, so minus c equals minus 16, so c equals 16. These are the two possible answers for C. And the way that we did that is we used that rule that we know that when x is 3, then we're going to get 10. And then we just solved it like we normally would. When f of 3 is 30, what's the value of C? So now when we plug in x is 3, we're going to get 30. So plugging in x is 3, we're going to get 30. 3 to the 3 is 27. Plus c equals 30, minus 27, c equals 3. Again here, when f of 3 equals 54, so that means x equals 3, and then we're going to get 54. So when we plug in x is 3, we get a, b, 3 to the 3 equals 54. 3 to the 3 we know is 27, a, b equals 54. And dividing it by 27, we're going to get a times b equals 2. So we didn't know what a was and we didn't know what b was, but we solved it together as a unit. And that's our answer. F of 1 is 5. So let's start with one thing at a time. Let's start with f of 1 is 5 and see where that gets us. So that means when I plug in x equals 1, I need to get 5. So you have a, 1 squared, plus b, 1 to the 3, and that's going to get us 5. Let's simplify that. You have a times 1 plus b times 1 equals 5, which is just a plus b equals 5. Now we have another condition here that when x is equal to negative 1, we need to get 11. So then you have a times negative 1 squared plus b times negative 1 to the 3, and that has to get us 11. Negative 1 squared is just 1, so that becomes a. And negative 1 to the 3 is negative 1. So that's minus b equals 11. So what we have here is we have a plus b equals 5 and a minus b equals 11. So we know how to solve that from chapter 2. In this case here, we could just add them together because that will eliminate the b's. So you get 2a, the b's cancel out, equals 16. So then a just equals 8. That's our answer. So you have to solve simultaneous equations in this question. Again, we have multiple steps here. Let's see, when f of 0 equals 5, so that means when x equals 0, we're going to get 5. So plugging in x equals 0, we get a times 0 plus b equals 5. A times 0 is just going to cancel out so that we know that b equals 5. So once we know b equals 5, b is always equal to 5. So we could rewrite this as f of x equals ax plus 5 because b is a constant. I didn't specify that in the question, but b is usually a constant. Now let's do f of 10 equals 15. So when x is 10, we get 15. So let's plug in x is 10. And then we're going to know that f of x equals 15. So solving it for a, we get minus 5 minus 5. 10 equals a times 10. So then divided both sides by 10, we get a equals 1. So b equals 5 and a equals 1. So 5 plus 1 equals 6. They wanted a plus b. Now here, there's a shortcut to do this question. I'm not sure if you realized. Okay, let me first say that this here is the equation of a line. Okay, so that's the equation of a line. We know is y equals mx plus b. When you have f of 5 equals 8, that means when x is 5, the corresponding value is 8, that's basically the y value. F of x is the same as y here. So when you plug in x is 5, you're going to get 8. That's the same as y equals 8 because y is f of x. So that's essentially the point 5, 8. And here, when we have f of 2 equals 3, that means when x is 2, we're going to get y equals 3. So this is 2, 3. Basically, this is the x because we know that f of x, that's the x, and that's going to be what we get when we plug in that x, that's basically the y. So these are the 2 points that we have. So when it's asking us for the value of m, we know that that's the slope. So we could do y2 minus y1 over x2 minus x1. That'll be 8 minus 3 over 5 minus 2. That's 5 over 3. And that's our value of m. Now I'm not really sure if there was... I didn't really do it out the other way. I'm sure you could solve this out with simultaneous equations, but I created this question so that you would realize first that this is the equation of a line and that this f of 5 equals 8 is the same thing as saying 5, 8, meaning the x value is 5 and the corresponding y value is going to be 8. And then so on for this also. So this was a little bit harder to realize this question, but if it comes up now, you'll know. This one involves multiple steps. So f of 0 equals 2 can be translated to when x is 0, we're going to get 2. So let's plug that in. When x is 0, we're going to have a times 0 to the b plus c equals 2. And then 0 to the anything is just going to be 0. So this is going to go away. And then we know that c equals 2. So now c is always equal to 2. So we could have f of x equals ax to the b plus 2. So we could go to the second condition. That's going to be when x equals 1, we're going to get 5. So let's plug in when x is 1, we're going to get 5. And now 1 to the anything, it doesn't matter what the anything is, that's going to be 1. It doesn't matter if b was 1,000. 1 to the 1,000 is still going to be 1. So that's going to be 1. So let me rewrite it. 5 equals a times 1 plus 2 minus 2 minus 2. So you're left with 3 equals a times 1. 3 is equal to a. So a equals 3. So now what we have, we need a little bit more space here. So we have these two. Let's start up here. We have f of x equals, we know that a is 3, x to the b plus 2. The next condition says that when x is equal to 3, we get 29. So we're going to plug in when x is 3, so you get 3 times 3 to the b plus 2, we're going to get 29. Now let me just do some erasing so we have more room here. Okay, so let's solve this out now. Minus 2 minus 2. 27 equals 3 times 3 to the b. We can't multiply these together here for reasons that we explained in the exponent chapter. What you need to do is divide this first by 3, and then you get 9 equals 3 to the b. So then we know that 3 to the 2 equals 9, so b equals 2. So we got that c equal 2, we got that a equals 3, and we got that b equals 2. I know it's a little bit messy. So altogether, 2 plus 2 plus 3 is going to be 7, and that's our answer. So I believe that we got a is 3, we got at the end, we got that b is 2, and then we got that c is also 2. So that's going to equal 7. I have an equation here for the population at time t. That's p of t equals 100 times 2 to the t. That means when I plug in a different number for t, I'm going to get a different number for the population. So year 3 is going to be when t equals 3. And year 5 is going to be when t equals 5. So let's see p of 3, which means the population at year 3. That's going to be 100 times 2 to the 3. 2 to the 3 is 8, and then times 100 is 800. What about p to the 5? Meaning the population at t equals 5. 100 times 2 to the 5. 2 to the 5 is 32. Times 100 is 3,200. So how much did it grow? So we do 3,200 minus 800 is going to be 2,400. So the population grew by 2,400 in those 2 years. Again, we have one of these.